Hi everyone, welcome back to the channel. This is the last video in AC series circuit series. In this video, I will discuss the problems of RLC series circuit. To summarize, in RLC series circuit, the impedance is given as R plus J XL minus XC and current is calculated by V upon Z. Now this current can lag the voltage or lead the voltage depending upon the value of inductance and capacitance. So in case of series circuits, when we draw the phasor diagram, since current is common to all circuit elements, current is considered as reference. Voltage across the resistance is in same phase. Voltage across the inductor leads the current by 90 degree. Voltage across the capacitor lags behind the current by 90 degree. VL and VC, their resultant will be either in upward direction or downward direction depending upon which one is more. Let's say if VL is more than VC, then the resultant is in direction of VL minus VC, and resultant of VL minus VC and VR is supply voltage and this angle phi. Now current lags behind the voltage, so this is a lagging power factor case. Or we can have the case when the voltage across the capacitor is more in comparison to voltage across the inductor. Let's say this is VC, VL. VC is more than VL, so the resultant is in same phase with VC. Then we have the resultant voltage V, this is angle phi. Now this current leads the voltage, so this is a leading power factor case. Now how to calculate active power, reactive power? They are same irrespective of whether it's RL series circuit or RC series circuit or LC series circuit. We calculate the active power using formula VI cos phi, reactive power VI sin phi, and apparent power is V into I. So let's start with the problems. The first problem is a circuit takes 3 ampere at a power factor of 0.6 lagging when connected to 115 volt 50 hertz supply. So I1 is 3 ampere, V1 is 115 volt, power factor is 0.6 lagging. So it means this is a RL series circuit. Another circuit takes 5 ampere at a power factor of 0.77 leading. I2 is 5 ampere when connected to same supply, so V2 is 115 volt. Power factor is 0.707 leading. So when it's a leading power factor, it means this is an RC circuit. If the two circuits are connected in series across 230 volt 50 hertz supply, then we have to calculate the current in the circuit, power consumed in the circuit, and power factor. So it means the circuit looks like this: R1 L, R2 C, applied voltage is 230 50 hertz, 230 volt 50 hertz. We have to find out the current, power factor, everything. Now in order to find out the current, we must know that what is the value of R1, what's the value of XL, R2, and what's the value of XC. Now how can we find out the value of R1, R2, XL and XC, we have the ratings, voltage, current, power factor. From voltage and current, we can calculate the impedance, which is V1 by R1, 115 by 3. So this will give us the value of impedance magnitude as 38.33. Power factor is 0.6 lagging. 0.6 lagging. So from here we can have the value of phi 1, that is cos inverse 0.6, which will give the value of phi as 53.13. Phi 1 is 51.13. R1 is Z1 cos phi 1, 38.33 into 0.6. This one is 23 ohm. XL is Z1 sin phi 1, 38.33 sin 53.13, that is 0.8. So this one is 30.664 ohm. So we can say Z1 is R1 plus J XL, 23 plus J 30.664, which can be written as 38.33 and angle is 53.13 degree ohms. So this is how we can express the impedance in polar form. Similarly, we can calculate the impedance of second circuit from the voltage and current of second circuit. Voltage is same 115, current is 5 ampere, so Z2 is 23 ohm. Phi 2 is cos inverse power factor 2, 45 degree. R2 is Z2 into cos phi 2. So R2 is 23 into 0.707. So this one is actually 16.261 ohm. XC2 is Z2 into sin phi 2, 23 into 0.707, same 16.261 ohms. We can write Z2 as R2 minus J XC2, 16.261 minus J 16.261, which one is actually 23 angle minus 45 degree. So this is how we express the impedance in polar form. Now both the impedances, they are connected in series, so Z is equal to Z1 plus Z2. Z1 38.33 and angle is 53.15. Z2 is 23 angle minus 45. So this gives us the value of Z as 41.82, angle is 20.14 degree. This is the value of impedance of the resultant series circuit. Now I is V by Z. Supply voltage is now 230. Z is 41.82. Angle is 20.14, which gives us the value of resultant current in the circuit as 5.499 and angle minus 20.14 degree amperes. So the magnitude of current is actually, we can say 5.5 ampere, and this lags behind the voltage by minus 20.14 degrees. So we need to find out the power factor. Power factor is cos of minus 20.14, which is 0.939. Since our sign is negative with the angle, so it's a lagging power factor. We need to mention this always, whether the power factor is lagging or leading. And the last one is we have to find out the power. Power is VI cos phi 230 into 5.5.939. So active power is 1187.65 watts. So we have to find out the power consumed, that is actually active power only. Now let's move on to the second problem. The second problem says a choke coil having resistance of 10 ohm and inductance of 0.5 Henry are connected in series with a 20 ohm resistance, 0.1 Henry inductor and 50 microfarad capacitor. So we have a RLC circuit which is connected in series with a choke coil. This one is choke coil, 10 ohm, 0.05 Henry, and this is connected in series with the resistance, inductor and capacitor. Resistance value is 20 ohm, inductor 0.1 Henry, capacitor 50 microfarad. We have to find the voltage across the choke coil, and that is written as V1. This voltage we need to find out, and the RLC series combination, okay, V2, when the supply voltage is 200. So the circuit is connected to an AC supply of 200 volt 50 hertz. So we have to calculate V1, V2, active power, reactive power, apparent power, and also we need to draw the phasor diagram. Now in order to calculate this V1 and V2, we need to find out V1 will be, if I is the current through the series combination, it will be equal to I into Z coil, and V2 will be equal to I into Z of RLC series circuit. For that, we need the value of I, and I will be equal to V upon Z. So let's calculate Z first. Z will be R1 plus, not, let's say this is not R1, this is R coil plus XL coil plus R plus, sorry, JXL plus JXL minus JXC. So we need to find out the reactance of the coil, reactance of the inductor and reactance of the capacitor. So XL coil will be equal to 2 pi F inductance of the coil. 2 pi into 50, inductance of the coil is 0.05 Henry. So XL coil is 15.71 ohm. Then XL is 2 pi FL, 2 pi into 50. Inductance of the inductor is 0.1 into 0.1. So this one is 31.42 ohm. Then we need to calculate XC, which is 1 upon 2 pi FC. 1 upon 2 pi into 50 into C is 50 microfarad. 50 into 10 raised to the power minus 6. We need to change the capacitance value in farads. So this gives the value of XC as 63.66 ohm. So the impedance of the circuit Z is resistance of coil, that is 10 ohm, plus JXL of coil plus 20 ohm resistance plus reactance of the inductor J31.42 minus reactance of capacitor. So this Z is 34.25 and angle is minus 28.855 degree ohms. This is the value of impedance of this circuit. Now once we have the value of impedance, then we can calculate the current as V by Z. 200 divided by 34.25 angle minus 28.855. So current is 5.839 angle 28.855 ampere. You can use the complex mode of the calculator for these calculations. So what we see that the current is leading the voltage by 28.85. The supply voltage, which is 200. So when we are writing 200, it means 200 angle 0, because 200 angle 0 is simply 200. The imaginary part is 0. So if the supply voltage is our reference, then with respect to that, the current is leading the voltage. Although in case of series circuits, we all say that the current is taken as reference, but in the numerical problems, supply voltage is usually given to us and then we calculate the current. So when the voltage is given without any angle, so we say that this is at angle 0, and correspondingly all the angles which will come with the different voltages and angles, they will be with respect to this supply voltage V, because we have written this as 200 angle 0 or simply 200. So next is we need to calculate V1, which is I into Z1. I is 5.839, 28.855, and what is Z? This is R coil 10 ohm plus reactance of the coil plus J 15.71. So V1 is 108.74 and angle is 86.386 volt. So it means this voltage V1 leads the voltage V by angle 86.386. Similarly V2, which is voltage across the RL series circuit, it will be equal to I into Z2, where Z2 is R plus JXL minus JXC. I is 5.839, angle is 28.55, R is 20, XL is 31.42 and XC is 63.66. This gives the value of V2 as 221.53, angle is minus 29.33 volts. So from here we can draw the phasor diagram. Now in phasor diagram, we have voltage V. V1 is 108 and angle 86, means this is leading the voltage V by angle 86 point. Here we will have V1 and this angle is 86.386. V2 is lagging behind the voltage V by 29.33. Let's say this is V2. Sorry, this is 29.33 and current I leads the voltage by 28.85 degrees. 28.855. So this is what we have in the phasor, or we can say the resultant of this V1 and V2 is voltage V. So we have to calculate the active power as well, which is VI cos phi. Voltage is 200, current is 5.839 and phi is 28.85. 5.839 cos of 28.85. So this will give us the value of active power as 1022.993 watt. Reactive power VI sin phi 200 into 5.839 sine of 28.85. So reactive power is 563.485 volt ampere. Reactive apparent power V into I 200 into 5.839, so it's 1167.8 volt amperes. And the last thing is we need to calculate the power factor as well. Power factor is cos phi, cos of 28.85, this one is 0.876, and as the angle was positive, so it's a leading power factor. Now let's move on to the last problem in this video. This says a pure resistor R and a pure capacitor of 15.91 microfarad are connected in series with a choke coil. So we have a resistance and capacitance R 15.91 microfarad. This is connected in series with choke coil. Choke coil means another resistance and inductor. Let's say its resistance is RL, inductance is L. The current through the combination is 0.25 ampere. Okay, this is given. So here we have supply voltage. The voltage across the choke coil is 40 volt. Across choke coil is 40 volts. Across the capacitor is 50. And across the resistor is 20. The voltage across the combination of resistor and choke coil is 45. Okay, so let's just redraw this. Firstly, draw the choke coil, then resistance and capacitance, so that we can mark the voltages clearly in the circuit. RL, R, C. C value is given, that is 15.91 microfarad. The voltage across this capacitor is 50. Across the resistance is 20 volt. Across choke coil 40 volt. And across the resistance and choke coil is 45 volt. This one is also given. Calculate supply voltage, frequency, power loss in the choke coil, and also draw the phasor diagram. Now frequency we can calculate from C, voltage across the capacitor, and current, which is 0.25 ampere. Because XC is VC upon I. VC is 50, current is 0.25, so XC is 200 ohms. Also XC is 1 upon 2 pi FC, which is equal to 200. So frequency is actually 1 upon 2 pi into 200 into C, 400 pi into 115.91 into 10 raised to the minus 6. So this gives a value of frequency as 50.02 Hertz. We have the value of voltage across the resistance as well and current through the resistance, so we can calculate resistance. So R is VR upon I. VR is 50, so not 50, it's 20. VR is 20, current is 0.25, so resistance is 80 ohm. Then from voltage across a choke coil, we can calculate the impedance of the choke coil because this voltage is across a series combination of resistance and inductor. So ZL will be equal to VL by I. VL is 40, I is 0.25. ZL is actually root RL square plus XL square. So root RL square plus XL square is 160. So from here we will have one equation that RL square plus XL square is equal to 25600. Let's say this is the first equation. And we have the voltage across the coil and resistance series combination, that is 45. So we can have the impedance of this. The impedance of this will be R plus RL square plus XL square into current will be 45. So we can say voltage across the resistance and the coil is I into Z of resistance and the coil. So this was, or impedance of the series combination of resistance and coil is 45 by 0.25, which is actually 180. RL plus R square plus XL square is equal to, so under root equal to 180, or RL square plus R square plus 2 RL R plus XL square is equals to 32400. We have already calculated the value of R. When we substitute that value and solve this equation, then this equation becomes RL square plus XL square plus 160 RL equal to 2600. This is the second equation. So we have two equations and two unknowns. 1, 2. Two equations, two unknowns. From these two equations, we can calculate the value of RL by subtracting the first equation from the second. So that will give us 160 RL is equals to 400, or RL is 2.5 ohm. So once we have the value of RL, then we can calculate the XL from here, that XL square or XL is equal to under root 25600 minus RL square, and answer for XL is 159.98 ohm. Since we need to calculate the supply voltage will be I into Z. Now we have calculated all the parts of impedance, R plus RL plus JXL minus JXC. So 0.25 into R is 80, RL is 2.5, XL is 159.98, XC is 200. So the supply voltage is 229.236 minus 25.88 is the angle with the supply voltage. So supply voltage is actually 229.236 volts. This is the magnitude and this one is the angle. Now if we have to draw the phasor diagram, current is reference, voltage across the resistance, that is VR, is in same phase with this. Voltage across a choke coil that leads this. Voltage across the capacitor lags behind the current by 90 degree, and the resultant voltage also lags behind the current by 25.88 degrees. So one thing which we are left with in this problem, that we have to find out the power consumed in the choke coil. So that will be I square into the resistance of the choke coil, 0.25 square into 2.5. This one is 0.15625 watt. This is the power consumed in the choke coil. I hope these problems will help you out in solving the problems related to AC series circuits. In the next video, I will come up with the parallel circuits. If you consider the content on this channel useful, please consider subscribing the channel. Thanks for watching the video.